The word perpendicular means, well, let me show you the symbol for perpendicular because I will use it often today. It's an upside down T. If you are taking geometry, or when you get to Math 2, this is the symbol that they use for perpendicular. Perpendicular means it creates a 90-degree angle. Perpendicular means, here's the symbol for it, creates a 90-degree angle. Just in case. So what do slopes have to do with parallel and perpendicular lines? In case you didn't know what perpendicular was, it's with that it creates a 90-degree angle. Let's write down the word parallel. Parallel. Here's the symbol for parallel. They're just two vertical lines that are next to each other. It looks like railroad tracks without the bars going across. Symbol for perpendicular, the symbol for parallel. These parallel lines never intersect. And are in the same plane. Two lines are parallel if they never intersect and they have the same plane, or they're in the same plane. So what I want to show you is I want to show you what that looks like. So I want to draw a little bit of graph paper on my paper. I suggest you do the same. I'm going to draw 4 lines, 1, 2, 3, 4 on my x-axis. I'm going to draw 4 lines on my y-axis. I'll recenter this up a little bit. And I'm going to draw 2 lines. I'm going to draw my first line, goes through this point 0, 1, and then it goes through this point 1, 2, 3, 1, 3, 2. Then what I'm going to do is I'm going to take my, bump that, let me make that centered. Here's my line. I'm going to call it line L. Okay, so we have my first line. I'm going to do a second line, but I'm going to do it in a different color. I'm going to go through this point, which is 1, 0. Then I'm going to go over 1, 2, 3, and up 1, 4, 1. And I'm going to draw this one in red. Do you need some water, Savannah? No. Okay. If you look at these 2 lines, the blue line and the red line, line L and line M, are these parallel or perpendicular? They are parallel. Now there's something special about these 2 things, and I'm hoping it will help you to answer this essential question. What do slopes have to do with parallel lines? What do slopes have to do with parallel lines? What do you notice?
Both of the lines have the same slope.
Both of the lines have the same slope. What's the slope of L? Do you know? Up 1 over 3. So the slope is 1 over 3. What about the slope of line M? Up 1 over 3. The two slopes are the same. Parallel lines never intersect, are in the same plane. They also have the same slope. So if I think about this blue line, line L, that's the equation y equals 1/3 x plus 1. That's the blue line. That's line L. Line M, on the other hand, ooh, this one's going to be an interesting one because the y-intercept is a fraction. Is y equals 1/3 x minus 1/3. It is. Trust me. You don't have to know how to figure that out. Just trust me on it. Okay? When you look at these equations, the one thing that should jump out at you is their slopes are the same. So even if you didn't have the picture and you're trying to decide, is this parallel to this? You could know just by looking at these two values, the m's. Does that make sense to you? Second thing we need to talk about is, what about perpendicular lines? Let me draw you one. So first I'm going to go from here. I'm going to go up 1, 2, 3 and to the left one. Draw this one here in blue. And I'm going to call this line S. I'm going to write down the equation of line S. Y equals -3 x plus 3. Line S, does this make a perfect right angle? Let me see, because I actually have a little tiny protractor on this thing. I have a here, and then that from here to there is 90 degrees, and this line lines up perfectly with that line, and this line lines up perfectly, and my bullseye's right on it. This is a perfect 90-degree right angle. That means that line S is perpendicular to line L, and technically perpendicular to line M as well. You'll learn that in Math 2. What do I notice about the slopes? What do slopes have to do with perpendicular lines? Do you see the relationship? What's different between this slope and this slope? Blake.
It's flipped and the other one is negative.
It is flipped, and one of them's negative and the other one's positive. There are fancy words for that. Let's write down the fancy words. I'm going to write it up here, right next to perpendicular. They are negative reciprocals. Negative reciprocals. Their slopes are negative reciprocals. Their slopes are negative reciprocals. I'm going to write down what that means. And I'm running out of room over here, so I'm going to write it down over here. If slopes are negative reciprocals, let me adjust my camera a little bit. If slopes are negative reciprocals, what it means is this: negative reciprocals reciprocals. That's how I remember how to spell it. Reciprocals. It's OCALS. Means that they're going to be the opposite signs of each other. Opposite signs. Positive to negative. Negative to positive. They are going to be opposite signs, and they are going to be flipped opposite signs. That's what negative means. Reciprocals means that they are going to be flipped fractions. Ray, do you need one of these? Here you go. Flipped fractions. That's what that means. That's how we know if something is perpendicular. So let's do a couple of exercises real quick and to see if you get what I'm talking about. Okay? If I have a fraction of negative 1/5, okay? I have a slope. M equals negative 1/5. Okay? I'm going to write that down. And I want you to figure out the slope of a parallel line. That's why I'm writing the parallel symbol for you. And I want you to find the slope of a perpendicular line. A parallel slope, in the slope of this other line that we're trying to find is equal to negative 1/5. Can you figure out what the slope of a parallel line would be? And can you figure out what the slope of a perpendicular line would be? What I want you to do is I want you to put what you think it is and then look to see if you and the person sitting next to you have the same answer. Go ahead and look. Write it down. What do you think? Okay, show of hands. How many of you have, let's do the top one first, negative 1/5 for your parallel slope? Raise your hand. That is not everybody. Okay, that looks like about 60%. If they are parallel, then the slopes need to be the same. If they are parallel, the slopes need to be the same. If it's perpendicular, the slopes need to be negative reciprocals of each other if it's perpendicular. Which means I have to do the opposite sign from a negative to a positive. And I have to flip it as a fraction. Do I have to write it 5/1? Well, how do scholars write it? They would write it like just 5. Okay? Just curious, how many of you have 5 or 5/1? Either one is acceptable for perpendicular. Okay, that's still 60%. I need to do another one. That's what that tells me. Not everybody gets this. Let's do one more. If I have this line, y equals 2/7 x plus 16. And I want to know what the parallel slope is and the perpendicular slope is. The slope that is parallel, the slope that is perpendicular. You should be able to look at this and be able to tell what the parallel slope would be and what the perpendicular slope would be. Write down what you think it is. Eric, what do you think? What did you get for parallel?
2/7.
How many of you agree with Eric and think it's 2/7? Raise your hand. Oh my goodness, that's just about everybody. That much better. I like the second round. This is good. Perpendicular. Let's see. Miss Mendenhall. What did you get for the perpendicular slope?
I put 16.
16. How many of you put 16? That is incorrect. Let's try another one. Miss Knowles, what did you get?
I put negative 3.5.
How many put negative 3.5? Raise your hand. That is incorrect. Cian, what did you get?
So I got negative 7.
How many put negative 7 over 2? Raise your hand. Good. Okay. Oh, wow, that's a lot of you. A lot of you wrote negative 7 over 2. So let's re-explain. Yes.
Wait, I actually did put 7 over 2. I just switched it to decimal.
What did you say?
Negative 3.5.
Oh, that's the same answer.
Same thing.
Yes, it is. You're right. If I were to take 7 divided by 2, it goes in 3.5 times. That works. Makes sense. I'm still waking up. Thank you very much. So, the good thing is that the majority of you understand how to do this. This is perfect. Okay, but let's go back to Allie. Allie, do you understand? All we have to do is look at what's in front of the x. That's your slope. And if we want a parallel slope, it has to be the same. If we want a perpendicular slope, we have to do the negative reciprocal, the opposite sign, and flip the fraction. Simple?
Yeah.
Okay. So here's how it's going to look on your worksheets. Your worksheet is going to say something along the lines of this. Thank you. Write in slope-intercept form. Did he?
What?
On the bottom of your chair. Well, there's nothing.
No, that's just a sticker.
What's it on the chair? Was it on the chair?
What's the chair?
Joel's like a sticker on the bottom of your chair. Can't do that.
Okie dokie. So here's what number 1 looks like. Here's what number 1 looks like on your worksheet. Write in slope-intercept form a line that is parallel to y equals 2x minus 8 and goes through negative 1, comma 3. So I hope you know which one is, right? In slope-intercept form, a line that is parallel to this line. It has to be parallel to y equals 2x minus 8. If it's parallel, let me underline that word. You should know automatically what the parallel slope is because we just talked about that. Cece, what is the parallel slope for this particular line?
2.
I agree. It is 2. It has to be 2. And it says it has to go through this point, negative 1, 3. So what I would recommend you do is use point slope form to write it down. If you forgot point slope form, I'm going to write it over here. Point slope form, just in case you forgot it. Y minus y1, and I underline that, equals m x minus x1. I recommend that you use this with this x, this y, and your new, well, I guess it's the same slope as your parallel line. So let's write it out. Y, opposite of the y.
Negative 3.
Good, Jason. Equals, and I need the parallel slope. Parenthesis, x, and then I need, oh, I should write opposite, just to remind myself that I'm doing the opposite of the x and the opposite of the y. Opposite of the x. Whoa.
Wait.
Okay. So this is in point slope form. Now, some of the questions you can answer in point slope form, but for number 1, you can't because it says right in slope-intercept form. And so now let's review what we learned last time on 3.5b. How do I go from this to slope-intercept form? You distribute 2x plus 2. And then you add the 3. And you get y equals 2x plus 5. That's your answer. If you think about it, I'm going to prove it to you so you can get this idea. We have a line that's 2x minus 8. This line here is parallel to it because the slopes are the same. And I know it goes through negative 1, 3 because if I plug this into x, let's plug in negative 1. Let's do this in our head. 2 times negative 1 is negative 2. Plus 5 is 3. It gets this result. This is on that line. They are parallel, and that's on the line. That's how it works. Okay, let me give you an example like number 7. Number 7 says, determine if these are parallel, perpendicular, or neither. That reminds me of my freshman year. Little story. I had a girlfriend freshman year. She wasn't from the same school, elementary school, as I was from, but I met her, and she loved to pronounce words like she wanted to be special. So she would read this word, and I said, it's neither. And she goes, well, it's neither. And I'm like, neither? What? And 30 years ago, whatever it was, okay, I still remember how she made a point. Either. No, either. What? Okay, so I always thought that was kind of weird, right? But we were freshmen. What did we know? All right, there we go. Okay. Little side story for you. Little side story. No. Where does that come from, you guys? Come on. Jeez. I just think it's weird how some people pronounce words. That's all. What?
The I makes it either.
Oh, okay. Now I'm curious. How many of you pronounce it neither? Okay, okay. There's like 5 of you. That's 5 of you. All right. Just saying you're in the minority. That's all. That's all I'm saying. Doesn't mean, okay, here we go. Determine if these are parallel, perpendicular, or neither. Okay, now wait. Here's what I want you to do. Do you know what the top equation, do you know what the slope is of the top equation?
Yes.
What is the slope of the top equation?
-4.
Good, very good. And the bottom equation, do you know what the slope is the way it is right now? No, you do not. This is not in slope-intercept form. Because it's not in slope-intercept form, nor is it in point-slope form, we do not know what the slope is. This is in standard form. So we're going to have to convert this from standard form into slope-intercept form. How do we do that? We get the y by itself. I'm going to add x to this side. And then I get 4y equals x plus 14. And I'm still not done. I want the y by itself. There's something next to the y I have to get rid of. It's 4 times y. So I have to do the opposite of times by 4. So I need to divide by 4. And when I divide by 4, I divide everything by 4. And this puts it into slope-intercept form. Now, I hope you know when I divide by 4, 4 does not go into this x, and there's an invisible 1 there. So I'm hoping you know what the slope is of this equation. It doesn't matter what the y-intercept is. I don't care about this. What I do care about is what is the slope of this second line. Do you know? What does it say? The x is not part of the slope. That's a variable. I want the numbers. 1 over 4. Now when you look at negative 4 for the top equation and 1 over 4 for the bottom equation, are they parallel? Are they perpendicular? Or is it neither?
Perpendicular.
So keep in mind, in order to be parallel, they have to be the same. In order to be perpendicular, they have to be opposite signs and flipped. If this was a positive 4 and this was a 1/4, it would be neither because they didn't change sign. Keep that in mind. You're going to have to determine that on those 3 types of equations. The last example I'm going to do, backside. Last example is like number 12. Write a perpendicular equation that passes, thank you, Allie, this is for you. Come and get it. Write a perpendicular equation that passes through 6, negative 2. To y equals negative 3x plus 4. Does that mean right now or at 9 o'clock?
Right now.
You see the 9 right there?
Oh, okay.
I think it means 9 o'clock.
Oh, yeah. Okay.
That's why I was confused, because that's where a signature belongs. Okay, write in a perpendicular equation that passes through 6, negative 2, and I have y equals negative 3x plus 4. So this is the equation that needs to be perpendicular to it. So if I know what the slope is of this equation, the slope of this equation is what number?
Negative 3.
So then I have to know what the perpendicular slope is. I'll put a symbol next to my slope, the perpendicular slope. Do you know what the perpendicular slope is? Got to change the sign, and you got to flip it. Jur, go ahead and tell me what you think it is. 1 over 3. Do you agree with Jur?
Yes.
Good. He is correct. Write a perpendicular equation that passes through. If it passes through, let's go ahead and use point slope formula. Y opposite of the y coordinate is, change the sign, opposite, opposite, equals, what's the perpendicular slope we're going to use?
1/3.
X, opposite of the x. Now listen to what this says. Write an equation that passes through. Did it say write this in slope-intercept form? Is this an equation? Yes, it is. You can stop right here. Do not feel like you have to go further and put it in the slope-intercept form. Remember, point slope is preferred in higher level mathematics, so it's totally fine if it says write an equation. You can use point slope, or you can use slope-intercept. It is fine. Okie dokie.